Hello everyone. So in the last video we discussed about the uh, open loop and closed loop system and their applications in general way. But today we are going to discuss about the applications of control system with respect to power electronics, with respect to the power system, and with respect to machine control. Why? Because they are the three fields where we can able to control, especially related to the electrical perspective. Okay, so that's why I'm just telling you to where exactly we can see. So the best example in the power electronics, now I'm showing to you. So power electronic applications, so three-phase diode bridge rectifier, which is a open loop system, because as we already know, diodes are a unidirectional switches, and they can't able to trigger or they can't able to control. That's why they are called as a unidirectional and uncontrollable devices that are called diodes, right? So here, if you see, there is no feedback signals they can collect. Even if we collect, also there is nothing we can't able to do anything. So this is how this diode bridge rectifier is an uncontrolled device. What we'll call it as it is uncontrollable also we can say. So the best example for the open loop system in a power electronic perspective is the three-phase diode bridge rectifier only. Okay, but when it we change these switches from the diodes to either the diodes to IGBTs or SCRs or any other GTOs or anything, then automatically they inherently they have a switch will be there. So switch means either as a normal switch what we are having in our home, the power electronics also having a switch which can be controlled by the control system application that will be done through the this on and off signals. So that can be done through that one. So now we will see the closed loop control system. And now I am taking an example of three-phase IGBT rectifier. In the best example for the closed loop operation. If you see, this is the block diagram. So I am just replacing the diodes with respect to diodes to the IGBTs. Okay, here the diode bridge is there, and also the IGBTs are there. So this is a different example, but I'm to let you know about in the here the diodes can't able to control. That's why there is no feedback signal. There is nothing will be there. So no system. It is a combination of both open loop and closed loop. But here, if you see the whatever the reference voltage, here the reference voltage will be there and the carrier signal will be there, and that can be generating the switching pulses to control the output voltage or output whatever the current or whatever the motor it is connected or motor also. So this is the best example for the closed loop operation. This is for the closed loop operation. This is for the open loop operation. The best example in the power electronic applications. Okay. Now we will go to the power system applications. As a power system applications, if the voltage, whatever the voltage coming to our homes or whatever the industries or whatever it will be, for example, let's take it as an example for the homes, that is 230 volts. That 230 volts is a fixed one. If that is not controlled, means then automatically what will happen is wherever the generation is happening, after the generation transformation will be there, this everything, whatever the transmission sector, this all things will be collapsed and heavy noise will be placed at these places. So we can't able to even enter into that places if the voltage is not controlled. Then even this whatever the insulators, each and everything will be there, which is placed on top of the uh, overhead transmission lines. So that in the transmission sector, so those also can able to damage. And after that, the distribution substation, distribution transformers, this everything can able to collapse. Once even everything is collapsed, then automatically what will happen is whatever the voltage coming to our home, it will be never will be 230. It maybe goes to the 220, 210, 200, 180, 150 also, or it may beyond the thing. That means 230, 240, 250, 260, 270 also. So it is not even controllable. So that will be happens. If that happens, means whatever our equipments are there, those are all equipment will able to get damaged and everything will be going to not able to use also. So then when it comes to the if the power system application, the same power system application, if we control means then what will happen is then whatever the here what will happen is after the transmission and everything there will be a name, call it as a SCADA, SCADA, SCADA. Okay, SCADA will be there. So that SCADA, and also there are some surge arresters, some uh, insulators, some also some capacitors, each and everything will be there. Those will be taking care of this controlling part, and also automatic tapping of the transformers will be there. That tapping of the transformers also will going to control the voltage also. Okay, in that way, the whatever the voltage is coming from the generation point of view, also one way here also we are controlling, and after this one, the in the transmission to distribution also we will control, and after distribution also here in between the distribution transformers there also we are going to control. So multiple level of controls is there. Whatever the voltage is coming to our home is the 230 volts also. Okay, that is the best example in the power system application. When it comes to the machine application, so the machine applications mean simple examples as we already know. These are all whatever the very old things like simple old things where we can able to measure the weighing machines of weighing things and everything. They doesn't have any control. Whatever the weight we will put, we can able to control. Whatever the weight things thing will be there, it will show. But there are some equipments are there which are like motors which can able to control. That means, for example, if it need to move upside, then it need to come down, or if it need to left or it need to right, or whatever the machine need to run speeder or slower, or it need to be a circular motion or whatever it will be in ups and down motion, everything can be controlled with respect to the motor control. So these are the best examples for that one. So each and here if you see everything is having some boards are there, some control equipments are there. These are the controlling parts of this entire machines. The output of the machine is controlled. Okay, this is how the real life, not real life, the electrical applications of the open loop closed loop control systems. Thank you.